Okay, so welcome to our next topic, which is the kinetics for rectilinear motion. So, from the previous part about kinematics, again, kinematics is considering motion without or neglecting the applied forces. However, for kinetics, we are now going to consider now the force as the effect why a certain body move. Okay, so kinetics of rectilinear motion is a study of bodies in motion that considers the effect of forces, that's forces, on the moving body. For example, we have this applied force P and we're expecting it to move it to the right side. So with that, the effects of or the effect of force on the body is now being considered. So the motion of a body experience when it is subjected to an unbalanced system of force can be established using the following methods. There are actually three methods that we're going to use. First is force, mass, and acceleration, or this is the inertia. Then this one is the work and energy method, or the the law of acceleration. And then the third one is the impulse and momentum, or the third law of Newton, which is the reaction or action reaction law. Okay, so these are the three methods that um, would arrive in a certain answer or the same answer regardless of the method ng imong gamiton. So let's first tackle with number one, the force, mass, and acceleration, or known as the D'Alembert's principle. So it says here that a body in motion is subjected to a reverse effective force, or the REF, or the reverse effective force, and that's equal to mass times acceleration, because inertia is mass times acceleration. However, mass is equivalent to the weight over its gravitational acceleration, or that's W over G. That's why we replaced mass in terms of weight, directed opposite to the acceleration and acting at the center of gravity of the body. So, for example, a certain body um, is being applied by a certain force, then the expected motion for this one due to this acceleration is on the right side. Therefore, I mean here. So since the acceleration is on that here, I cannot there. So since the acceleration is on the right side, because we're trying to push or we're trying to move the body because of that force P, then there is an acceleration, and the acceleration would always be um, in the same direction with the motion. So REF is now opposite in the direction of the acceleration. It's always acting at the center of gravity. And since this is now forces that is now imbalanced, then we have to apply the equations of equilibrium such that it has a weight, so therefore there must be a normal force. And because of the motion nga padung sa right together with the same direction of the acceleration, then therefore the friction would now be opposite in the direction of the motion. Again, do not get confused that the friction would always be in the opposite direction of the motion. However, the REF, or the reverse effective force, would always be in the opposite direction of the acceleration and is always acting at the center of gravity. Okay, so from friction, you know already that frictional resisting force is equivalent to coefficient of friction times the normal force. Then we can now sum up using summation of forces vertical, and at the same time using summation of force horizontal to know the other elements such as REF, F, N, and a lot more. So let's proceed with our example.